So children, every chemical reaction has a mechanism, and for your competitive exams, you have reaction mechanism as a topic. There are several chemical reactions and you have to understand their mechanism. We will see today mechanism of two reactions. First, this one. It is very simple to understand. One chlorine has taken place of another hydrogen. Hydrogen has combined with another chlorine. Reaction finished. To write it is easy, but how it happens, that we need to understand. Now children, in chlorination of methane, a very important thing is light. Okay, it is written heat or light, but this reaction cannot be done using flame. If we will try substitution of methane using flame, we will get carbon and hydrochloric acid. There won't be any reaction, no substitution. So the heat which is used, it is of light, and being specific, ultraviolet light, for which sunlight is also enough. The kind of ultraviolet rays which comes from sunlight, some kind of ultraviolet rays they come. Okay, that ultraviolet light is enough for this reaction. Now, how it happens? Again, I want to bring you back to the topic of free radicals, because in this reaction, free radicals have a role to play. Now, children, chlorination of methane is a chain reaction. What is a chain reaction? Any one of you can tell me what is a chain reaction?
The reaction which occurs in a particular sequence, that is one after another.
Exactly. A chain reaction occurs in a sequence. It happens in such a way that one of the starting substance is again produced. In the chemical reaction, the starting substance is produced and the chain continues. How it happens will be more clear to you. Just look at the mechanism, children. Every chemical reaction generally has 3 steps. In substitution also there are 3 steps. First is how the reaction begins. It is called initiation reaction. Initiative, how to begin. Second step, how the reaction proceeds. So it is called propagation reaction. And how the reaction stops. It is termination reaction. The 3 major steps, I repeat: initiation, propagation and termination. Let us see how it happens. Fine. The free radical chain reaction, you can see. Initiation generate a radical intermediate. Radical is again the free radical. Simply free radicals can be called radicals also. Propagation. The intermediate react with a stable molecule to produce another intermediate and also product. Termination. The reactions stop. Let us see the first step. The initiation step. You can see, children, chlorine. This is a molecule of chlorine, which is a covalently bonded molecule. There are 7 electrons in each chlorine atom. They have shared one electron, and Cl2. Chlorine molecule is formed. Now, this chlorine molecule, when it is exposed to a light photon or ultraviolet rays, simply speaking, ultraviolet rays when fall on this chlorine, it splits. There is a fission or breaking. You can see that both chlorine atoms now have again 7 atoms. What we can understand here is this pair of electron which is responsible for one bond or a single bond, it breaks. And when it breaks, one electron goes back to chlorine atoms. And what we get here? What we can see? A chlorine molecule splits homolytically into chlorine atoms, or called free radicals, because they have got one electron each. This is the first step. Now, what is the next step after this? The next is propagation reaction or propagation step. How reaction proceeds? Children, these free radicals are highly reactive species. They are highly unstable. Now this free radical will move to methane, and chlorine, because of its high electronegativity, chlorine has tendency to attract electrons, the electronegativity, it will pull hydrogen. It will pull the hydrogen towards itself. But look here what is important. Can you see the single bond between the carbon and hydrogen?
Yes, ma'am.
A single bond is formed between how many electrons? Between how many electrons a single bond is formed? See children, this carbon has 4 electrons, 1, 2, 3, 4 in the outermost shell, and hydrogen with its 1 electron forms a bond. So whenever you see a single bond between two atoms, it shows that there are 2 electrons. Single bond is nothing but 2 electrons. Okay? So if there is a single bond between this carbon and hydrogen, it means there is 1 electron here, 1 electron here. When? Can you hear me? Students,
Yes.
can you hear me?
Yes, ma'am.
So chlorine, when it takes hydrogen, let us say when it steals hydrogen from methane, hydrogen comes only with 1 electron. Sorry. When the bond has 2 electrons, out of the with which hydrogen is connected, out of the 2 electrons, hydrogen takes 1 electron and it bonds with chlorine. But the 1 electron is left on the carbon. You can see. You can see that this electron is left. Okay? Now when this electron is left, hydrogen has taken its electron. Again, a free radical is formed. Which radical is this? Methyl radical. Now, what is the next step? Have you understood this one, children?
Yes, ma'am.
How this radical is formed?
Yes, ma'am.
Okay, now look next. Now this methyl radical reacts with chlorine molecule. Okay? It reacts with the chlorine molecule, and of this chlorine molecule, again between the chlorine molecule there is a single bond joined by, it means 1 electron here, 1 electron here. Okay? So the methyl free radical, it collides with this chlorine molecule, and the chlorine bond, the bond here is broken. Chlorine takes 1 electron and it forms a bond with methyl radical. As you can see, a chloromethane is formed. And again, a free radical is generated. This is the chain.
Excuse me, ma'am. Excuse me, ma'am.
Yes?
Here, in the when the Cl2 is broken, the bond between the Cl2 is broken. Is
Yes.
there the homolytic fission takes place?
Here? Yes.
And after the homolytic fission, there formation of the radicals.
The radical is formed. Here is the radical. And this radical, there is a breakage. It breaks. This chlorine atom takes one electron. It brings its electron here. A single bond is formed between this chlorine with one atom, and this chlorine is left with one electron,
Okay, okay, ma'am.
which will again propagate a new chain reaction. Okay. Initially, ultraviolet rays or the ultraviolet light broke the chlorine molecule, if you remember. Okay. But here we can see now within the reaction, chlorine free radical is being produced. Now this chlorine free radical can again react with a methane molecule, form a new radical, and the reaction can go on. But it is not possible that the chain will go on and on, because it is also possible that radicals can react with each other. When we are doing reaction, there are number of molecules. Okay, there are number of molecules. There are number of molecules of methane. There are number of molecules of chlorine and few chlorine radicals in the beginning. There are some possibilities that a chlorine radical can collide with another chloride atom. Another chloride free radical. All the chemical reactions are because of collisions of molecules. If a chlorine free radical collides with another chlorine free radical, some part, or what we can say, there is a wastage. What kind of wastage? Again, energy will be needed to break the chlorine molecule. It is also possible, you can look at the last step we saw, that this methyl radical is formed. These methyl radicals, instead of colliding with Cl2, if it collides with a chlorine free radical, it is also there, then the chain reaction will stop. Definitely we will get the product. If this one will collide, if this radical collides only with a free radical, then again we will get the product, but we will not get this. But children, the possibility of such things are less. Why? Because methane and chlorine molecules are more in number. Comparatively, the free radicals are lesser in number. But anyways, the reaction comes to end. There is termination also. This is how termination of reaction occurs. I just now told you, instead of colliding with a chlorine molecule, if the methyl free radical collides with the chlorine free radical, both are free radical, right? The chain will stop here. We will get the desired product, but the chain will stop. So reaction finished. Suppose this chlorine colliding with another chlorine free radical, Cl2 is formed, wastage. This CH3, methyl free radical, colliding with another methyl radical. Can you make a guess? What will be formed? CH3 plus CH3. What will be formed?
C2H6.
C2H6. Ethane will be formed, but we don't want ethane. So all these will make a reaction or bring the reaction to stop. Okay? So these are the termination steps. Fine? Again, we can see the overall reaction. Chlorine breaking into free radicals. Free radical chlorine colliding with methane and forming methyl radical along with HCl. The methyl free radical collides with the chlorine molecule, take off one chlorine and forms chloromethane, and again we have a free radical with us. which can initiate this step. So steps can go on and on. That's why it is a chain reaction. This is the overall reaction, children. Methane plus chlorine in presence of heat or light gives chloromethane and hydrochloric acid.